Hello everyone, welcome back to my channel. My name is Piyush and this is video number 32 in the series CK 2024. And as you can see, we have a very special guest today. Saiyam Pathak is with us today. Hello Saiyam, thank you for joining and thank you for giving us your time for showing our subscriber how networking works in Kubernetes. I'm sure many of you already know Saiyam. So he's been doing amazing work in CNCF and Kubernetes names, Kubernetes space for the past many years. And he's been not just working with Kubernetes and related, ecosystem tools, but he's also teaching that as well through his channel Cube Simplify and Cube Simplify Hindi. But I'll let Saiyam to introduce himself to the audience and then we'll start. Yeah, over to you, Sayam. Thank you. Thank you so much for joining.
Well, thank you so much, Piyush, for having me. Glad to be on the show and great work on the CKA series. I think we need more such content. So, more is less. So, always like we want more and more stuff to be created so that the path becomes easier for the people who want to get into cloud native or want to do certifications or want to understand, learn. So, yeah, great initiative and glad to be part of it and contribute little networking piece over there. And for those who do not know me, my name is Saiyam and I am the founder of Cube Simplify. And currently I work at Loft Labs as a principal developer advocate. Previous to that, I have experience at working as field CTO at Civo, and I have had previous roles in Oracle, Walmart, HP. So, and yes, I have been doing containers and Kubernetes for a long time now. It's always interesting. This space has never been less evolving. It has always evolved more and more and more. So you can always see with each Kubernetes release there is always something new to discuss, always innovation happening at all the levels. And recently Kubernetes completed 10 years and there have been celebrations all around the globe around Kubernetes 10th birthday celebration, which was great. So yeah, in this particular section we'll be discussing about a bit about Kubernetes networking and how it works and try to see it in a practical way, how things work.
Okay, cool. Awesome. Thank you. Thank you for the introduction, Sayam. I'm sure this will be an amazing video. I'm sure all the concepts that's been explained in this video will be helpful to everyone who is viewing this one. So I'm just gonna share my screen and that's yeah. Over to you, Sayam. Please go ahead now.
Cool. So before we dive into the Kubernetes networking concepts, or ETH0 and VETH, all that pairs, how stuff works internally, the thing I want to go back a little bit of history lesson that I always try to do. So the Kubernetes ecosystem is now 10 years old, and when it started, Docker was the only container runtime which was there that we call today. So it was the only thing that could run containers and package containers. So it was bundled directly. So Docker was bundled directly into the code base of Kubernetes. Now, as things got mature, the adoption got mature. There were other container runtimes with specifications like different things. Like Rocket came into the picture. Rocket is no more today, but Rocket came in, so the bundling was very difficult. So in future, the best thing at that particular point of time around 2016 time frame was to create a standardization, to create a specification, and to start building towards a road where we do not have to bundle Docker within the Kubernetes code base, and we can just have those interfaces lined up and people can plug and play their own choice of container runtimes that they want to use. So with this, there was born the OCI, which is the Open Container Initiative. Now, this initiative mainly has three sections, like mainly has two sections: image spec and runtime spec, and also the distribution, like how the image, the container image that we talk about, that you have been hearing throughout the series. So what the container image looks like, what the runtime of the image looks like, and where this can be distributed to which all repositories and stuff like that. So under this, so what happened was in 1.24 Docker support was removed, but that was a long journey. Like it started in 2016, and then when OCI came, Docker was not, at that particular point of time, Docker was not OCI compliant immediately, because Docker was born before OCI came into picture, but a lot of contributions towards OCI has been contributed by Docker as well. So Docker re-architected themselves, and the new architecture that looked something like this. So when and now you do Docker run, what happens is, and Docker itself is not only a container runtime, okay, it's a complete ecosystem. So you download Docker desktop, it comes with a fancy UI, it comes with a fancy CLI, it can do a lot and lot of things. So it's not only a CLI tool that just do container run and stuff like that. It has like the whole ecosystem, making the whole container creating and running easier, the whole UX easier. That's why it became popular, because it since beginning the thought process was same, that it's simpler, so it makes life simple. So when you do Docker run, what happens is the request goes to the daemon, the Docker daemon, but the daemon does not start the container. Now this is very important to understand, and this is interesting also, because what exactly runs the container is not even containerd. So what happens is Docker also internally now uses containerd, and containerd basically manages the life cycle of the container, like keep a check on the life cycle of the container, but it doesn't start the container. It does the request to the shim, which is the Docker shim, and shim also doesn't start the container. It passes the request to run low level container runtime, which is called the OCI runtime, which is this particular thing is compliant to the OCI initiative. So run C starts the container, and shim maintains the connectivity between the running container, and run C starts the container and exits. It's short-lived process. So it starts the container and exit, and we can actually point our pod or the handler. Basically, we have the containerd.toml file in the Kubernetes nodes. We can add different segments to target the low-level container runtime. So we can target. That's how WebAssembly was able to, so that's how WebAssembly. So that's how you could have run. So that's how now you can run WebAssembly workloads on Kubernetes ecosystem as well, because the shim thing is the run wazi shim. So there is a new shim called run wazi shim, which also falls under the project like containerd project, and you can target that, and it will use run C. It will use the WebAssembly runtime instead to run your WebAssembly workload. So you can use the same workflow and target different, like you can use have a node with Kata, have a node with crun, have a node with run C, and whenever things go to a specific node, they are running with the pod specification. You can choose how your container starts now. So that's how the modern workflow looks like. And be it Docker or be it kubectl run that we do. So in Kubernetes also, what happens is you get a node. On node, you on one side you have kubelet, and on other side you have the CRI, which is the container runtime interface. And this CRI, which helps in making the kubelet talk to the container runtime, and container runtime can be containerd, cryo, even Docker, but Docker is not, like Docker is only supported via the Mirantis repository and stuff like that. But now if you see, most of the default standards have been moved to containerd, which is more lightweight, and cryo also people use. So let's come here. Yeah, let's come here. So as a user, what you do is, as a user, you hit, or I mean, you do a kubectl, or you do a curl request, or you do a REST API call, whatever you do, you just tell the API server that I want to run a particular Nginx pod. And then scheduler checks the best fit nodes and updates the pod spec that, okay, this is something, it has to run on this particular node. So the request goes to kubelet of that particular node, that, hey, this is the workload that you have to run. Now kubelet, again, in this particular scenario, you can think like we told this particular thing can be assumed to be kubelet, because kubelet doesn't know how to run a container. So what kubelet does, it start making the calls to the CRI, which is the container runtime interface. Container runtime interface passes that particular call, like it's the way of communication between the kubelet and the container runtime. Container runtime, for example, in this particular case, let it be containerd. So now it's the containerd's responsibility to start the container, and now when it reaches to containerd, it follows the same process, like it goes to the shim, it goes to the low level container runtime. Run C is responsible for starting the image. So containerd will, what containerd will do is, it will pull the image and get everything and do the specific calls to the low level container runtime, and things will get started. After this, interestingly, things go to CNI to attach the network interface. Now, this is the beauty of Kubernetes. Now, here you have to understand why Kubernetes have been such a successful system. So, Kubernetes is a very, a highly optimizable, highly pluggable system. You can add operators where you can add a choice of your container runtime, choice of your container networking solution. So you might have, when Piyush might have shown you the setup using KubeADM and stuff, there is the step when you add CNI plugin, because that is not by install. When you do a KubeADM init, you do not get, like, you do get mkdir, create those directory, export kube config file, but your nodes are not ready. Now that's because there is no default networking implementation that comes with bundling of KubeADM or when you install the Kubernetes cluster. What comes, it gives you the option. Okay, there is this thing called CNI, which is the container network interface that configures the network. What basically now it means is, see, in Kubernetes, every pod can communicate with every other pod. Okay? Every pod can communicate with every other pod. So it has to have an IP. So every pod on whatever node it is running will have a unique IP. Now this is very important. Now this IP, it has to get from somewhere, attach the network interface, make sure that this particular IP is available across all the nodes to be able to communicate with this. So all these things has to be done, and this is being done by the CNI, which is the container network interface. Obviously, any interface is just the specification, and then when you talk about the implementation, those are the products. For example, you have CRI, which is the specification. You have OCI runtime spec, which is the specification, and then you have CRUN, and then you have containerd, which are the implementation. So there is a specification, then there is a implementation. So for this also, CNI is the spec for defining the network. Like you should be able to add, delete, remove, watch, all that things that should be there in a particular implementation of the CNI. You can actually build your own CNI. So you can build your own CNI by doing a limited set of things, by implementing all those things that have been mentioned in the CNI. So there are different plugins. For example, you have Flannel, Weave, and Calico, and Cilium. Yeah, the one that is most used, I have put in the end. Yeah, Cilium has been is pretty fantastic. I use Cilium for everything that I do when I create Kubernetes clusters. So, and this is what I recommend as well, because it has uh, very rich ecosystem. Like not only like it has inbuilt network policies as well that you can use with Cilium. So there are a lot of things that you can do with Cilium apart from this, and this is the pluggable ecosystem. So now everything
So,
is done by
Sayam,
the,
sorry,
yeah.
sorry to interrupt you. I just have one question. So, is it fair to say that CNI is nothing but a set of standards that has been laid, and it actually resonates with the type of network interface that you want to use? It should have all those bare minimum features.
Yes.
So let's say we have like whatever features you have just told. So only an implementation with those set of features, it could have more, but only an implementation with those bare minimum features can only be integrate with Kubernetes. Is it fair to say that?
Yes, and if I can actually show you one thing. Yeah. So to your point, yes, CNI is the bare minimum that should be there. So you can see in the original specification. So this is GitHub, and you can put that link
Mhm.
in the description as well. So CNI defines 5 operations: add, delete, check, GC version. These are passed to the plugin via the CNI command environment variable. So you can see for each of them, like for each of them, what are the required parameters and what are the optional parameters that has to be specified. So, and the plugin consideration, a plugin must, so when some, for example, you Piyush is creating a plugin, So when you
Yep.
are creating a plugin, you have to obviously read through the spec. And when you come to this particular section, there are plugin considerations. So you have to read that
Hmm.
your plugin that you are creating must consult the pre result to determine the expected interfaces and addresses. So this should have this. Your plugin should return an error if not tracked
Correct.
to the invalid state of below, like firewall
Mhm.
rules, traffic shaping, IP reservation. So all these things are mentioned very clearly in what the CNI plugin, which is the implementation, should
Mhm.
implement. What all things are required to make it, that this is, but this particular thing is implemented. This is the CNI. Are
Correct.
all, everything is compatible with whatever mentioned in the CNI. So
Mhm.
everything is there, and you can see execution of network configurations, life cycle. So everything is mentioned. This is a very good read that you can do in the main spec. So this is the CNI spec
Sure.
actually.
Awesome.
So this
Awesome.
is the specification which we are actually talking about,
Okay.
and that's where you can also see here the CNI. Obviously, it's under CNCF, and it consists of a specification and libraries for writing the plugins to
Yep.
interface in the Linux.
Yep. Okay. Awesome. So yeah. So I mean, whenever someone is building their own CNI plugin, these are the instructions that they must follow. So these are not good to have; these are must have specification that they should have in their plugin, like whatever they are building.
Yes. So one more thing would be, I saw someone building CNI plugin from scratch. The first one, this also is there, but ah, how to write a CNI plugin from scratch is actually very good video that you can
Okay.
link. So CNI has this plugin based thing, like to add, the bridge, EVLAN, loopback, everything is there inside defined as plugin. So the add IP, like I know the main purpose is to attaching the IP address to the pod, but behind the scenes, it's not only one thing that is happening. There are a lot of other things that happens by each of the specific plugin which is defined in the CNI plugin. So now the request goes to the CNI, it attaches the IP address, and it returns the pod is running with the IP address, and you get it. Now what I understand is, okay, now we understand, okay, Docker was there, it was removed. We know the CRI stuff, we know CNI, which is the interface, we know some of the CNI implementations, Flannel, Calico, Cilium, Weave. So we can install the cluster and install a networking plugin of our choice, install the container runtime of our choice, and run the container. But let's actually try to understand from a practical examples, when you exactly run kubectl run nginx -f image nginx, it gets the IP. Can we kind of try to see and visualize the link? Because when the more we visualize, the more we try to understand what all interfaces are there, what all things are there. So for example, there is this pod. So you have a pod called shared namespace, and it has two containers. So this is a multi-container pod. So by now you should be knowing about the multi-container pod. Piyush might have covered that in one of the previous videos, what multi-container pod is. So, and this is where things will get interesting, because here you have two, but the IP is one, and how that happens. And they're able to communicate using local host. How that happens, we'll get to that point as well. So if you see, you have the pod one, sorry, pod name shared namespace, and you have two containers. That one is busybox, and one of them is, so one is p1 with busybox image, one is p2 with nginx image. So when you create, interestingly, what happens behind the scenes is, on the node on which it is assigned to, it creates the pod, and it creates three containers instead of two. It creates three containers. One of them is Zbox, one of them is nginx, which are defined over here, which is good, well, it works. And one of them is pause container. So pause container is something that gets created. It is basically used to hold the network namespace. So that was the only thing that it was created for, and that is the only thing that is actually it is being used for. That is why it has stayed from starting till 10 years plus in Kubernetes ecosystem. Container, the pause container still remains. So pause container will hold the network namespace, and that is the reason why we can have a single network namespace. Because what happens is, when you create a container, there is a network namespace, network namespace, that gets created. There are like 6 7 namespaces, IPC, UTC, all those spaces that created. Actually, that's what the pod is, right? You create the slices of all this, and then it becomes a specific container. So one of them is network namespaces, and it holds the network namespace together, and that is why these all have a same IP address. The IP address remains the same, and they are able to communicate internally using localhost. So that's how it happens. Now, how it communicates to other pods and stuff like that, we'll get to that particular point. Now, if you see, um, you'll get the pod and you'll be able to exec into the pod. So this is kubectl exec-it shared namespace. And if we do a IP address, we'll be able to see a loopback address. And another thing that we'll be able to see is the Ethernet address over here. It can be, it is not mandatory that it will be ETH0, because this particular thing is CNI specific. Now the names can be different, like ETH0, or it can be EN0LS, which we'll now see in some time in the example as well. So this is what it will happen. And this particular thing, ETH0, is the Ethernet interface via which this will try to communicate with the virtual Ethernet pair of the host. So this is where it will try to communicate there. And if we see IP netns list, this will give a list of the network namespaces that has been created. And let's see how it actually does. Yeah, pause container, I have told you, it's sleep creates network namespace and holds the container D creates the network namespace, and pause container holds that particular network namespace. And when we do this, we'll do everything practical. So when we see, you can see these three, specifically the network namespace, is being held by the container. This is very important for any of the process. So this is the process -p. So for every process, the network namespace will be held by the container when it comes to the containers and the Kubernetes part. Now this will be done more. Yeah, let's do this first. So inter node pod communication, how does that happen? So what happens is, this is the node, and it has the Ethernet interface. Now virtual Ethernets are created for each of the pod gets created, and each of the pod also gets their own. In the root namespace, you get the virtual Ethernet, and inside the pod you get ETH0 pairs for each IP addresses. Now this ETH0 will talk to the virtual Ethernet on the root, and via the bridge, which is maintaining using the arc tables and stuff like that, it will pass on to this particular node. So what happens is, A to B, how traffic goes to ETH0. V ETH, this one, V ETH1 acts as a tunnel, and traffic goes to the root namespace. Now bridge resolves, the bridge is there to resolve the destination address using the arc table. So there is this thing called arc table, by which the bridge uh, resolves the destination address. Like this particular traffic that I'm sending, it has to go to this particular pod, is done by the arc tables. Now V ETH1 sends the traffic to the pod B. That's how the inter-node pod communication is being done. And you can add, what you can do now next is add another node and try to do the same thing while it's ETH0. This particular thing will come here. So node to node communication will also follow the similar. So let's try to see that in action, because when we try to visualize things, it will be more. In fact, we'll be using Killer Coda. Killer Coda is gives you a free Kubernetes playground. So even if you want to try, or you can try any of the Kubernetes cluster Piyush might have, help you create it on different cloud environments, or even locally, you can try all these things. So we'll see kubectl get pods. We don't have anything yet. Uh, I'll put all the comments. So all the resources will be given to Piyush, and he'll be adding the GitHub repository. but for now there is a networking GitHub. So we'll create a pod, simple pod. kubectl apply -f kubectl get pods. It's container creating, and very soon it will go to running state. So container is running, and we do kubectl get pods -o It's running on node 1. kubectl get node. This is a 2-node cluster. We have control plane and node 1. What we'll try to do is we'll go to another tab and we'll SSH onto the node, because if you saw in the diagram, most of the things that we have to see on node, how the networking is there, right? All the Ethernet pairs, virtual Ethernet pairs. So SSH node 1. Now we are in the node 1. And what we'll try to do next. So first we'll get the list, like the network netns list. So we can see we have 3 over here. Now what we'll do is we'll also grep nginx, because that's that we have run. So you can see 3510. That is important that we have to do, because we have to get the all name. So what happens is when we do lsns, it doesn't show all the namespaces. It doesn't show the network, like it only shows the mnt and pid namespace. It doesn't show all the namespaces. If we want to show all the namespaces, then we have to use this particular command, which is lsns id, and give the process id over there. So now it gives you all the commands from which a container actually is formed. You can actually see a PID, MNT, IPC, UTC, net user C group. This forms a particular container. Now you can actually manually create all these yourself and manually create a container as well. There is a video, I think, by Liz Rice and also Ivan on how to create this without using Docker and any of the fancy tool, like how to create this manually. I think you should, if you go through that process, you'll get to know even more stuff about this. Here you can see the one that we discussed, this particular namespace, specifically the network namespace is being held by pause container, the pause process over there. And now what we can do is we can check network namespaces, all the network namespaces which are there, and these are the namespaces list as well. And now what we'll do is we'll exec into the namespace to see the IP links. Now, that's where things get interesting, because we'll be able to see that IP link. So let's do that, and we need to replace the namespace by the actual namespace. So 33, this is the one that we created. There are other pods as well. That's why there are more namespaces. And see, as I told you, there is a loopback and a Ethernet address, ETH0 address over there. Now this particular thing is important, IF9. Show you why. Because this is the corresponding link on the node. Now we'll use this. And now we'll be able to see how the Calico has added link. So you can see link network namespace CNI. So Calico has created this, and this has been added to the CNI. The CNI has added, because in this case it's Calico. So the CNI has added this particular link over here. For every pod that you create, there is this particular thing that gets created. And we can also see IPADDR. You can also see on this particular node, there are different stuff which is there. Like it has its own. So yeah, the host is having ENP1S0. This is another naming convention for ETH. So for example, I showed you node has its own, right? So even this IPADDR, if I do, it will have its own ENP1S0. It's just the naming convention. You can read more about that. but that's how it does. So you can see 9, this particular thing, links to network space. For everything, it will try to create this. And then your IP table rules are managed by proxy component. So bring that up. Plus your core DNS is acts as the service discovery. You might have already discussed the core DNS stuff. So core DNS gives you the service discovery, so that when you call a particular service by by its name, like svc dot default dot local, the naming convention, that is how it resolves. So it resolves using the core DNS thing. So these are the building blocks of networking. So let's try to show this in another way as well. I think I had it twice. Yeah, let's try to understand from a different workflow as well. So we already shown the link. Let's clear this. Okay. For somehow it's not working. Okay, now it's good. It got reconnected. Okay. So IP link show, it is showing the thing with the pod that we created. Listing of the network namespaces, we already did this previously. As now inspecting the namespace, what we can do is we can actually exec into the namespace IP link. We already did that because since I have written it, I want to follow the same flow for the verification that the traffic flows. So we were at this point previously as well. Now with pair. Now this is the with pair on the host that we are talking about. So for Calico, it creates like this, like adds Cali and then creates that with pair. For some, it might be just naming convention for different CNI plugin. And now what we can do is we can use this tool to verify the with pair connection for the interface. And you can see it's working as expected. So that's the check how the ETH and ETH pairs are being monitored as well. If you go, you can also see here kubectl get pods, kubectl exec -it, and if I go inside this and do IP addr, we can see the same, like this is what we actually found from this command. So whatever stuff that I have done coming to the node, and because you might not have node access all the time, so coming to the node, getting the namespaces, and then getting into executing into that particular namespace to show the link. This particular thing is exactly similar to executing into the pod directly, and doing a IP address, and it will give you that same E0IF9 over here. So this is the Kubernetes way of doing things using kubectl, and that is the way where you can actually go on the host and do all the checks and command, like how you want to get into the namespaces, list the namespaces, get onto that, because this is the host. Right, this is the host where your container is actually running. So this is the host where your container is actually running. So everything, all the network namespaces you can see on this particular host. That's why I logged into nodes 01, and this is where you can see the namespaces, and you can see what's happening, and you can do a lot of things. Here you can do, but things will be limited. You won't be able to check the veth pair and all these. You won't be able to see the link show of the node that it has created those veth pairs on the nodes. So that's what the CNI does. Not only assigning the IP, but behind the scene, all the linking, creation of those veth and eth pairs, and eth of the pod is also being handled by the CNI. So CNI, the plugin, the CNI Calico Cilium or whatever you're using, plays a very crucial role in making sure that your pods are able to communicate with each other. So even if I create ctl run nginx hyphen hyphen image nginx, so get pods. So what we do, kubectl exec, and first we'll do get pods hyphen o wide. Every pod, like I said, will get its own IP address. That's the CNI has done it. Also, we can do kubectl exec hyphen it shared namespace, and we can run the command. I don't know if curl is there, but we can try to p1. Okay, curl is not there. We can try it from nginx maybe and give it 4 here. So you can see the pod is able to communicate with other pod directly over the IP, and it doesn't require NAT, or nothing is required. It's the default behavior. And in order to prevent this, there's this concept called network policies, which is very essential from any Kubernetes certification point of view, whether it's CK, CKD, or CKS. So network policies is something that you can use to restrict the traffic going from one namespace to other, one pod to other, one application to other. That is what you will be doing. So that was the gist about Kubernetes networking. I hope you got something out of this particular video, how and what Kubernetes networking is, and how you can just see things happening to understand it a bit better.
Thank you so much, Sayyam. Thank you. So I'm sure it was really a helpful session for everyone watching this video. If you found this helpful, let us know in the comments below, and also try to subscribe Sayyam's channel. He has been producing some amazing stuff around Kubernetes, around cloud native, and everything that is there for you to learn. If you are a beginner, if you are an intermediate, or even an advanced level professional who has been working on these things for quite a long time, then also it will be helpful. And this video was not really like, there won't be any question in the CK exam that will test your Kubernetes networking on the topics that we have discussed today, but it is just to give you the fundamental knowledge of how Kubernetes networking works behind the scene. So it depends on your curiosity, it depends on how much you want to learn, how much uh, deep you want to dive into the networking concepts. And we'll share all the links, we'll share all the videos and everything. You can learn more about it, you can read more about it, and it will be really helpful. So thank you once again, Sayyam, and it was pleasure talking to you, it was pleasure having you on the show. And like I've been thinking about having a collab with you for quite some time, but then I thought it would be a good this particular playlist would be a good opportunity for me to introduce you to my audience, as well as it will be more helpful than just doing a regular podcast, because here you are sharing all the knowledge, all the learnings that you have got from your past experience, from your learning and everything. So thank you once again, and I wish you have a good day. We'll talk soon.
Thank you for having me.
Thank you.